Welcome to video number 8. In this video, we're going to take a look at how we can archive application data. This way, the way the app looks when the user closes it is the same way it'll look when they reopen it later. Specifically, we're going to make a very simple version of the Reminders app that comes on every iPhone. So the Reminders app allows users to add little notes to help them remember things they have to do and places they have to go, and saves and then presents them in the table view. We're going to do essentially the same thing, but it's going to be a little simpler than the real Reminders app. Before we get started, I just want to warn you that this video is going to introduce a lot of new classes and new concepts, so I highly advise that you take it slow and make sure you understand every step thoroughly as we go on. So let's get started. Of course, let's open up Xcode, create a new project, stick with single view application template, click next, and I'm going to name the project Simple Reminders App. Next, and of course, as always, I'm going to save it on the desktop. So first, let's open up main.storyboard. And the first thing we have to do, graphically, is insert a navigation bar to the top of our view controller. If you remember from a few videos back when we looked at navigation controllers, recall that navigation controllers automatically insert a navigation bar at the top of the view for you. And it also extends the navigation bar to the top of the screen. Again, remember that as of iOS 7, the status bar, which again is on the top, and lists the carrier, the Wi-Fi signal strength, the time in the middle, and then a battery life indicator on the right. Remember that the status bar in iOS 7 hovers above whatever application is running. It's no longer a separate chunk of the screen, and you'll see why we're discussing this in just a few moments. So, find the object library, scroll down, and look for this right here, which is a UI navigation bar, and drag it to the top of the view. Now first, let's drag it all the way to the top and run the application and see what it looks like. Okay, so obviously this is no good. The status bar is literally getting in the way of our navigation bar. So let's quit the app, and let's drag the navigation bar down 20 pixels, which is exactly the height of the status bar. We can do that by opening the size inspector in the utilities panel and changing the Y value from 0, which means the very top of the screen, to 20. So now our navigation bar starts 20 pixels down from the top of the screen. Let's run the app again and see what it looks like now. Okay, so that's a little bit better, but visually it's still a little unsettling to the eye. It would look a lot better if behind the status bar was the same color, the same light gray color that fills the back of the navigation bar. Fortunately, Apple has provided a method as of iOS 7 for us to do exactly that. Believe it or not, there's a protocol called the UI Bar Positioning Delegate protocol that allows us to solve exactly the problem we're facing. It's a very simple protocol with one method, and let's see what that method looks like in the Apple documentation. So we're going to Google UI Bar Positioning Delegate Protocol. Now you can see here that there are 3 different classes that conform to this protocol: navigation bars, search bars, and toolbars. And again, here's that one method. And the use for this method is to tell the navigation bar how it should lay itself out in specific scenarios. So for us, we want the navigation bar to extend to the top of the screen, and we can use this method to accomplish that. So we're going to copy the method header, close the browser. Now first, we have to set the delegate for the navigation bar. So right click and drag from the navigation bar to the view controller and set the delegate outlet, and save. Now we can go to viewcontroller.m. Now here, we're going to be writing quite a bit of code, and it's all going to be placed in our view controller's implementation file. So to keep the file a little bit more organized, we're going to use something called pragma mark. Pragma mark is a macro that allows you to mark specific important areas in a source code file. So at the top here, we have a sort of mini browser, and all the way to the right is a drop down that lists all the methods implemented in this file. So far we only have view did load and did receive memory warning, and you can see that these two are implemented. Using pragma mark, we can add markers to this list. This is obviously useful because it'll help us browse our viewcontroller.m file a little bit more efficiently. So that looks like this. Now you can see here we have in bold listed our mark. So again, we're going to use this to mark the different pieces of our viewcontroller's implementation. So let's name this mark UI bar positioning delegate protocol. Now let's paste the method. Now this one argument, as you've seen with the table view data source protocol, is where the bar that's calling to this method will insert itself so you can reference back to it should you need to. But you can see that the type is not UI navigation bar. It's ID, which means any object, and then the brackets here denote that this object conforms to a UI bar positioning delegate protocol. So again, this can be one of three different classes, a toolbar, a search bar, or a navigation bar, and all three conform to, which means understand how to communicate with, the UI bar positioning delegate protocol. In other words, they all know to call this method to their delegate to figure out how they should be positioned. Now, very simply, we can return a constant, and one of the options, the option we need to use is UI bar position top attached. So we return this constant, the navigation bar sees this constant and knows to extend itself to the top of the screen behind the status bar. Now really quick, before we run the application, we're going to go back to this drop down here, and you can see we have mark UI bar positioning delegate protocol, and beneath it is our method. So just to make it a little bit more organized, let's add a marker that marks the end of the bar position delegate protocol. So very simply, pragma mark end UI bar positioning delegate protocol. Perfect. Okay, so let's run our application. And as we hoped, the navigation bar extends to the top of the screen behind the status bar, and this is much more visually appealing. Okay, so now let's get started implementing a table view that lists all the reminders the user has created. So first, we need a place to store all of the reminders the user has added. The most obvious choice for this is an array, or an NS Mutable Array. Previously, we've used NS Array objects for storing lists of strings, but when you create an NS Array instance, once it's initialized, the array of objects that it stores references to is not mutable, meaning it cannot be changed. You cannot add or remove any objects to an NS Array. Fortunately, we have another class called NS Mutable Array, and with this type of array, you can add and remove objects at will. So let's go to viewcontroller.h and add an NS Mutable Array instance variable for storing all the reminders the user creates. Very simply, let's call this reminders. Okay, so next, in viewcontroller.m, let's initialize an NS Mutable Array to be stored in our reminders pointer. So at the bottom of the viewDidLoad method, very simply, reminders equals NS Mutable Array alloc and init. So at this point, we've created an NS Mutable Array object, but it's empty. It doesn't store anything, so its count is currently 0. Now let's go back to main.storyboard and add a table view to list all of the reminders. So again, in the object library, scroll up, find the table view icon, and drag onto the view. I'm going to place this directly beneath the navigation bar and extend it to the bottom of the view. Now very quickly, I'm going to run the application just to show you that the table view, since it was the last thing we added to the view, is above the navigation bar. And you can see that it's cutting off the bottom line on the navigation bar that essentially separates the bar from the rest of the view. So we can fix this very simply by clicking on the navigation bar and going to Editor, Arrange, Send to Front. So now we've just told our view that the navigation bar should be displayed above every other subview in the view. So if we run the app again, you can see that problem is now fixed. Let's set our table view's delegate. Right-click from the table view, drag to the view controller, and connect the data source outlet. So now let's implement our table view data source methods. For this too, we're going to use pragma mark. So pragma mark UI table view data source protocol, and we'll add the ending pragma mark. Okay, and now inside, let's implement our table view data source methods. This far, we've always used 3 data source methods to give our table view the rows it should display. But it turns out that the first of the 3 that we always implement, the number of sections in table view method, is actually optional. And if you don't implement it, the table view will see that it's not implemented and automatically assume that it should display only one section. This way we can leave that method out and save a few lines of code in our viewcontroller.m file. So again, by not implementing that method at all, the table view assumes to display one section. So we're going to implement the other 2, the table view number of rows in section method and the cell for row at index path method. So int table view number of rows in section. Now here we're going to return the amount of objects in the reminders array. So very simply, return reminders count. So we're going to have 1 row per object in the reminders array. Let's implement our final data source protocol method, the cell for row at index path method. We're going to go with our standard implementation. So first we're going to check to see if the table view has a reusable cell. If not, we're going to create one. So we're going to have our reminders array store a series of NS string objects. This way we can just grab whatever object is in the reminders array at this index and set the cell's text labels text property to that object. So first let's grab the string that corresponds with this row. Of course we can use the object at index path method and pass in the index path.row property. And now we give the cell's text label text property this string, and we can return the cell. So obviously, if we run the application at this point, even though we fully implemented our table view data source methods, table view is empty because the reminders array is empty. So now we need to add a way to allow users to add new reminders to the list. Obviously, there's an endless possibility of interfaces you could present the user with for adding new reminders to the list. The way I like to do it is to present a user with a pop-up that has a text field inside, or a UI alert view. That way they can enter the new reminder in the text field and then press a button attached to the alert view to confirm the action of adding a new reminder. So let's add a plus button to the right of the navigation bar. Let's quit the app, go back to main.storyboard, and if we scroll down in the object library, we have something here called a UI bar button item. This is an object that you can use to insert buttons on the left and the right of a navigation bar. So we can click and drag from the object library to the right of the navigation bar, release, and now with the bar button selected, open the Attributes Inspector in the Utilities pane, and you can see here we have an identifier field. Currently it's set to custom, which means you can give the button whatever text you want, but there are some presets that come with the UI kit, and one of them is an add preset. Choosing this changes the button to display a very nice plus symbol to denote to the user that tapping on this button will allow them to add something to their reminders list. So now we can go to the viewcontroller.h and declare an IB action for that button, and to keep it simple, we'll just name it add. So now back to main.storyboard. Right click and drag from the button and connect the add action. Now let's implement our add method. So again, when the user taps the Add button, we're going to present a pop-up or a UI alert view with the text field inside so they can enter whatever reminder they need to enter, and then they can tap on the Add button to confirm adding this new reminder to their list. So let's go to viewControl.m. After the viewDidLoad method, I'm going to add 2 pragma marks to mark all IB actions. So in between the 2 marks, we will implement any actions that will be connected to our view controller inside of our main.storyboard file. So pragma mark IB actions and pragma mark end IB actions. So let's take a look at our drop down here, and you can see that using these pragma marks we can keep a very nice organized list here for traversing through all the methods implemented in this file. Okay, so IB action, add, and in here we're going to create a UI alert view object and present it to the user. So we can do that like this: UI alert view. Let's call it add reminder alert view equals UI alert view alloc init, and now we're going to set some properties. First, we're going to give it a title. Add reminder alert view title equals enter reminder. Next, we have to set the alert view style property to tell the alert view to display a text field. By default, alert views display a title and some message, and then there's some buttons on the bottom. A good example of this is anytime you open an application for the first time and it wants to send you push notifications, iOS confirms that you want to allow this application to send push notifications. And then there's a cancel button and a confirm button. But that alert just has a message, just a long string of text underneath the title and above the cancel and confirm buttons. We want an alert view with a text field instead of a message. So again, we can use the alert view style property, and we can give it the constant UI alert view style plain text input. You see there's another option for login and password input. This will make a reminder that has 2 fields, one for usernames and one for password. There's a default, which is the one we just discussed, where it just displays some string of text as a message. At the bottom, there's a secure text input option, which will present a secure text field, the text fields that are used for passwords. But we need the plain text input style, so we're going to pass in that constant. Now we have to give our alert view 2 buttons, a cancel button and an add button. We can do that like this: add reminder alert view add button with title, cancel, and then another one. Next, we have to set its delegate to our view controller so that when the user does commit the add action, we will be notified in the form of that delegate method, which we'll see in just a minute. So again, since we're inside viewController.m, we pass self to the delegate property, which denotes that its delegate is to be this object, whatever object this code is being executed from or inside. And finally, we display the alert view on the screen very simply with the show method. Okay, so now let's run our application and see what happens. So if we click on the plus, we have a very nice alert view that pops up. The title says enter reminder. Then the user can type in their reminder text and then click cancel if they want to cancel this action, or add if they want to go through with it and add this new reminder to their list. Now obviously, it doesn't actually do anything when we press the add button because we haven't programmed it to. So now we have to use the UI alert view delegate protocol to actually add that new string that they just entered to the reminders array. So since this is an extension of the add IB action, I'm going to leave it inside the IB actions pragma mark, but I'm going to add one more pragma mark just to say that this is part of the alert view delegate protocol. Again, just to keep things organized. I'm not going to add the end pragma mark for this one. And the delegate method we want to use looks like this. So alert view did dismiss with button index. So this will be called whenever the user taps one of the buttons attached to the alert view, and this variable here will store the index of the button they tapped on. So the first button, the cancel button, has an index of 0, and the add button has an index of 1. So if the button index is 0, we're just going to return so we don't execute any of the code in this method. In other words, if they've pressed the cancel button, we don't want to go through with the addition of this new reminder to the table view. So if button index equals 0, return. If it's not 0, which means it has to be 1 since there's only one other button, we want to add this new reminder to the reminders array. Very simply, we can do that like this. First, we want to grab a reference to the text field that sits inside of the alert view so we can get its text. We can do that like this. Alert view. Now again, remember that when this delegate method is called, the alert view will pass in a reference to itself so we can reference back to it to get whatever piece of information from it we need. So we say alert view, text field at index. This method allows us to get a reference to any text fields inside the alert view. Now, since we use the alert view style plain text input constant here when we set the alert view style, the alert view only has one text field, and that text field is at the 0th index of the alert view's array containing references to all the text fields that are displayed inside of it. But if you use the login and password constant when setting the alert view style property, there would be two text fields. The username text field at index 0 and the password text field at index 1. But again, we only have one text field, so we access it by passing in the 0 index to the text field at index method, and now we can get the text that the user entered very simply by accessing the text property of our alert view text field. Lastly, we can add this new reminder to the reminders array using the add object method and passing in the new reminder string. So let's run our app and see if, when they press add, if the new reminder is added to the table view. So we click the plus, type in some reminder. So even though we went through with the addition of this new reminder, it never shows up in the table view. The reason for this is we have to tell our table view to reload its data. We have to tell it to refresh and update all the rows it's displaying. We can do that very simply with a method called reload data. So first we have to make an IB outlet and connect it to our table view so we can reference the table view in our .m file and tell it to reload. So let's get that out of the way first. Connect it in main.storyboard. And now, back in our alert view did dismiss with button index method, after we add the new reminder to the reminders array, very simply, table view, reload data. Now let's run the application. Perfect. But now you can see even though the table view updates and displays the new reminders, it's not very appealing visually. Literally, the table view just refreshes and instantaneously displays the updated reminders array. So, let's use some methods that come with UIKit, of course, that allow us to animate the insertion of a new row. We can do that like this. So instead of table view reload data, we're going to get rid of that. First, we have to open up with a method called begin updates. In the last video, we looked at how you can animate transitions of certain properties on a view. And we always began those animations with the UIView class method, begin animations context. This method, begin updates, is kind of analogous to that method, but for table view animations, specifically table view insertion and deletion animations. So, using this method, we're basically opening a context for table view animations. Also, similarly, analogous to the UIView commit animations method, the method we use to end the context and go through with the animations, we have a method called end updates. So now, anything in between these two methods, or in this sort of context, we can have animated. So we do that like this. We use a method called insert rows at index paths with animation. But the first parameter of that method takes an array containing all the new index paths of all the new rows that are going to be inserted. So first we have to make an array containing the sole index path of this new row. So first, how do we get the index path for this new row? Well, there's a method that belongs to the NSIndexPath class called indexPath4RowInSection. So we pass in a row index and a section index, and then we get back an NSIndexPath object that contains that row in that section. So first, let's create the NSIndexPath object. IndexPath for new reminder, we'll call it, equals, again this is a class method, so we call to the NSIndexPath class, IndexPath for row in section. Well, the section we know, the section is 0, there's only one section in our table view. But how do we get the new row? Think about it logically. If the reminders array has no objects and the user adds one, the index path for this new row will be 0. If the reminders array has one reminder and then the user adds a new one, that new row's index will be 1. If it's the third row, the index will be 2. If it's the fourth, the index will be 3. So the pattern here is the index for this new row is going to be the new count of the reminders array minus 1. So, very simply, reminders count minus 1. Next, let's embed this index path object in an NS array, because again, that's what the animated method expects. So, NS array with index path equals NS array with object. And we pass in the index path for new reminder object. Now this is a class method, an NSArray class method, that allows us to create an NSArray instance with just one object. And finally, we insert the row and have the insertion be animated. Table view, insert rows at index paths, pass in our array containing the sole new index path object. And then with row animation, here we can pass in one of a series of constants that allow us to communicate to the table what style of animation this insertion should be. Fortunately, there's a UI table view row animation automatic constant. You can see all the other options listed here, but the first one, the automatic constant, tells the table view to figure out what the most appropriate animation for this particular insertion is. So let's pass in the automatic constant. Now we can save and let's run the application again and see what we've got. So again, we click the plus button, type in some string, click add, and you can see the insertion of that new reminder was animated. When the table view is completely empty and you insert a row, the new row is simply faded in. But if there already are existing rows and you add a new one, and this is the beauty of the automatic constant, any rows after that are animated by sliding down from beneath the previous rows. Okay, good. So let's quit the application, and next let's provide a way for the user to delete rows. First we have to add an edit button on the left side of our navigation bar. So let's go to main.storyboard again. Again, drag a bar button item object to the left side of the navigation bar, and very simply double click and change this text to edit. Now we have to add an IB action to be coupled with this new button. Connect the action, and now let's implement it. Fortunately, table views are designed so that most of the work in allowing the user to delete a row is already implemented. Table views have a property called editing. When the table view is not in the editing mode and that property is set to no, the table view just displays some static rows. However, on the other hand, if we put the table view into the editing mode, it'll automatically display those red circles with the minus symbol inside on the left of each row, and then by tapping on that icon, the row will slide out to the left and the delete button will slide in from the right, and then the user can tap on the delete button. Now, that part is just the part that takes care of the view. So visually, it seems to the user that they've deleted a row. But when they tap the delete button, we need to actually delete that row from the reminders array, so we need to update our model to reflect these changes the user has made to the view. And to do that, we can use another UI table view data source protocol method that we'll look at after we're done implementing our edit method. So first, let's make a boolean to store the new editing mode for our table view. So, by using the exclamation symbol, we negate the value that's currently stored in this property. So, in other words, if the edit button is tapped and the table view is not in editing mode, that property, which is currently no, will be negated and set to yes, and we're going to store that new updated editing boolean and save it in this boolean value new editing mode. Next, we're going to actually change the table view's editing property to update its editing mode. So, table view, set editing, new editing mode, animated yes. Using this method, we can have the table view animate the change on its editing property. So, let's run the application and see what this looks like now. So let's add some rows. And now tap on the edit button, and you can see automatically the delete icons are placed on the left side of each row. And if we click on one of them, the delete button appears, but tapping on the delete button doesn't actually do anything. And now, if we tap on the edit button again, those delete symbols disappear and the table view goes back to normal. Before we go through with committing to deleting a row, let's make it so that when the user taps the edit button and the table view goes into editing mode, the edit button's text changes to done, and then when they press on it again, the text will go back to edit. So we can do that like this. First, we need an IB outlet connected to the edit button so we can make changes to it. Connect the outlet. And now, if new editing mode equals yes, edit button title equals done. We're also going to change the edit button style so that it looks like a done button. Otherwise, if the table view is now no longer in editing mode, we'll set the edit button back to normal. Okay, so let's run the application and see what that looks like. Okay, good. Perfect. Now, let's implement a new table view data source method to allow the user to actually go through with the deleting of a row. That method looks like this. So the method is called table view commit editing style for row at index path. Now the reason it has a parameter for the editing style is because even though by default the editing style is to delete a row, there's also the insertion style. So I'm sure you've seen at least one app where in each row is a plus button. Actually, a good example of this is the contacts application. When you're editing a particular contact's phone numbers, to the right of each phone number is a plus button, and tapping all that inserts a new row beneath the row whose plus button you tap, and you can insert a new phone number. But in our application, the addition of a new row is already handled, and the default editing style is delete. We don't have to make any use of this variable in our application. Okay, so now for the part where we actually delete a row. So first, we have to delete from the reminders array the object, the reminder, that corresponds to the row that they tap the delete button on. Fortunately, we can use the index path object, as we've done with the self-for-row index path method, to reference the row that the user is trying to delete. So let's actually delete that object from the reminders array. So very simply, reminders, remove object at index path dot row. Okay, so at this point, we've removed whatever row the user tried to delete from the reminders array. So that row, as far as our model is concerned, is actually gone. But now we have to update the table view to show the user that the row was actually deleted. We can do this using a method similar to the one we used before to animate the insertion of a row. This method is called delete rows at index paths with row animation. So again, we have to open up an animation context with the begin updates method, close it with the end updates method, and finally table view delete rows at index paths. So we're just going to make an NS array with one object, and that object is going to be the index path object, so fortunately it's already made for us. And we're going to pass in the same constant, row animation automatic. Okay, so now let's run the application. So let's add a row, add one more, put the table view into editing mode. Perfect. So now you can see that row is actually gone. It no longer exists in the table view or in the reminders array. It's important to always make sure that your view matches your model. So whatever data is stored in your model has to always be correctly displayed to the user in the view that corresponds to that model. Next, let's make it so the user can actually edit a reminder. So the way we're going to do this is when the user puts the table view into editing mode, the text label is going to disappear and a text field is going to appear. Then, simply by changing the text in the text field, that reminder will be updated in the reminders array. This part is going to get a little messy, or maybe off-putting is a better word. So as I said in the beginning of the video, again, I highly advise you go very slowly and make sure you understand every single part as we go along. Alright, so let's quit the application. And first, let's insert a text field into each row that appears when the user taps the edit button. Okay, so first, let's make a pointer to point to a text field. Next, let's create that text field. So, in the case that the table view doesn't have a reusable cell, and this if statement passes true, and we create a new cell, we're going to also create a text field and place it inside of the cell. So we can do that like this. Text field equals UI text field alloc. We're going to use the initWithFrame method to give our text field exact coordinates for where it'll be placed in the cell and a width and a height. I already have these numbers worked out. So we're going to use the cgrect make function. For the x value, we're going to use 7. For the y value, we're going to use 6. And for a width, we're going to use 260. And height, we're going to use 32. Okay, so now we've created our text field. Next, we're going to set its border style to rounded rect, so the text field has a nice line going around it that's rounded at the edges, so the user can see that this is indeed a text field. By default, text fields have no border. And in this particular scenario, it's fair to assume the user is not going to understand that the text label just transitioned into a text field unless the text field does have a border around it to indicate that it is indeed a text field. So we can do that like this. Text field dot border style equals UI text border style rounded rect. Next, we're going to set the text field's alpha to 0. So by default, we want this text field to be invisible. Next, we have to give our text field something called a tag. A tag is an integer that you can append to a view so that later on you can reference that view by talking to its superview or the view you placed it inside using a method called viewWithTag. And you'll see why we need to do this in just a moment. So let's give our text field a tag of 101. Finally, we have to add our text field into the cell's content view as a subview. Okay, so now we've created a text field with the right dimensions and origin. We've given it a tag, we've set it to be invisible, and we've added it as a subview to our cell. Now, in the case that the table view did find a reusable cell, and this if statement passes false, we still need a way to reference the text field. So, append an else clause to the end of the if statement, and inside of it, we're going to set the text field pointer that we've declared up here to point to the view inside the cell's content view with the tag 101. The reason we do it this way is because we need to stick with the pattern of making cells reusable. If we didn't do it this way, if every single time the cell for row at index path method was called, we made a new instance of UI text field and added it as a subview to the cell, then even though the cells would be reusable, the text fields inside the cells wouldn't be. This way, we only create a text field when we create a cell. If the cell already exists, then so does the text field because we created that text field when the cell was created. So in the case that the cell already exists, we access the also already existing text field by using the viewWithTag method and passing in the tag that we appended to the text field, which in this case is 101. So only when a new cell is created do we create a new text field. When the cell is being reused, we also reuse the text field in that reusable cell. Okay, so now in both cases, in the case that a new cell is made or in the case that a cell is being reused, we now have a reference to a text field that we've inserted into our cell's content view. Now we need an if statement to see if the table view is in editing mode or if it's not. If the table view is in editing mode, inside of this cell we want to hide the text label and show the text field. If it's not in editing mode, hide the text field and show the label. So if table view editing, meaning the table view is currently being edited or it's in editing mode, we want to hide the text label and show the text field. Otherwise, we'll do the opposite. Show the text label and hide the text field. Okay, so now let's run the application and see if it works. Okay, so if we put the table view into editing mode, you can see that it doesn't work. The text field is never shown and the text label remains visible in the cell. To fix this, we have to update the table view. So once the table view is put into editing mode, we need to tell the table view to redraw all of its rows. This way, the cell for row at index path method will be called again for each visible row, and this will give us a chance to hide or show the text field. So let's go to the edit action, and here, after we set the table view into editing mode, let's tell the table view to reload its data and run the application now. Okay, so let's add a reminder. Put the table view into editing mode. Okay, now you can see that the text field does show and the label hides, but it's not animated. Also, you can see the text field isn't displaying any text. Let's go back to Xcode and set the text field's text to be the reminder string that we've pulled for this row. And next, let's animate the transition between hiding the label and displaying the text field. We can do that in the edit method by, instead of using reload data, we use a table view method called reload rows at index paths with row animation. So first, we have to figure out what rows do we want to reload. We could reload every single row, but if a row isn't currently being displayed, or in other words, it's been scrolled off the screen, and of course this will only happen when you have so many rows in your table view that it becomes scrollable, those rows, the ones that aren't on the screen at the time that we reload, don't need to be reloaded because they'll automatically be reloaded when the user scrolls down or up and reveals those rows. So the only rows we need to reload are the ones that are currently visible. Fortunately, there's a method called index paths for visible rows that we can send to the table view, and it'll give us back an array containing index path objects for all the visible rows. So very simply, table view, reload rows at index paths, table view, index paths for visible rows. With row animation, we'll use the automatic constant. Okay, so now let's run the application again. Let's add 2 rows. Put it into editing mode, and you can see very nicely whether we're going into editing mode or coming out of it, the text label and the text field are shown and hidden with a very smooth, quick animation. Alright, so now we have to make it so that changing the text in the text field actually changes the corresponding row in the reminders array. To do this, we can use the UI text field delegate protocol. So first, we have to set the text field's delegate to self, or the view controller. We can do that in our self row and index path method. Text field.delegate equals self. And now we need to implement two text field delegate methods. One called text field should return, and another called text field did end editing. Okay, so let's go to the bottom of our view controller file, add some new pragma marks, UI text field delegate protocol, and end UI text field delegate protocol. Okay, so again, the first method, text field should return a text field will call this method to its delegate whenever the user taps the return key at the bottom right of the keyboard. If you return yes in this method, the text field will add a return character. In other words, it'll break to a new line. If you return no, you basically disable the user from adding return characters to whatever text that is being displayed inside the text field. So we want to return no. Next, we have the method where we'll actually update the text that corresponds to this row in our reminders array. That looks like this. Text field did end editing. Now first, we have to figure out which row the text field that's calling to this method is sitting inside of. So all the text fields, even if there were 100 rows, all the text fields call to the same delegate, our view controller object. So with all these possible different text fields messaging our view controller to tell it that its text was updated and it's finished being edited, we need to figure out which row this text field is sitting inside of. In other words, we need to figure out which table view cell object this text field is in. We can do that like this. With table view cells, its content view is embedded in 3 super views. So first you have the table view cell, then you have another view, inside of that view is another view, and inside of that view is the content view. So we reference the text field and we call the super view method 3 times, and this will get us back to the table view cell. You don't have to worry too much about the intricacies of how table view cells are layered and how exactly this method will get us back to the table view cell. Just know that you can take any subview that you add to a cell's content view and call superview on it 3 times, and you will get back to the original cell in which all of these subviews exist. Okay, so now we have a pointer to the cell that this text field is sitting inside of. This way we can figure out the corresponding index path. So next, ns index path for cell equals table view, and we have a great method called index path for cell where you can pass in a table view cell, and the table view will tell you the row that corresponds to this cell. So index path for cell, we pass in the cell, and now we know which row to change in our reminders array. So finally, reminders, replace object at index path for cell dot row with object text field text. So we're going to grab the text field's text, the newly updated text, and replace the object in the reminders array with this new string at the correct row, the row that corresponds to the cell that the text field is in. Alright, so let's run our application and let's try editing a row. Alright, so let's put our table view into editing mode, change the text, done. Perfect. You can see that the reminder on that row was actually updated. Okay, so we've come pretty far. We're almost done. The final thing we have to do is make it so that when the user quits the app, their list of reminders is saved so that when they open the app later, the reminders that they already created are still there. This is where we'll see how to archive application data. So every application on any iOS device has automatically a Documents folder inside of it. This is a folder specifically generated by iOS for every application for developers to place important files that help the app function in any way they need it to. For us, it's going to be saving the list of reminders to a file, specifically a plist or a property list file. So fortunately, we have a class called NSKeyedArchiver that can, believe it or not, take an NS array and archive it to a plist file for us. It will archive the array in such a way that when we reopen the app later, we can unarchive that property list file and perfectly, completely, exactly recreate the original array that we had when we archived it. The first thing we need to do is make a method that will allow us to reference the documents directory in our application so we know where to store our archived plist file. So let's quit the application and create that method first. So underneath the viewDidLoad method, we're going to make a method and call it application documents directory, and it's going to return a string with a full path to the documents directory for our application. Okay, so we have a function here called NSSearchPath for directories and domains. We pass in some constants to tell it what directory we're looking for, which again in our case is our application's documents directory. It'll return whatever paths it finds in an array. We know that the documents directory will be the first object in that array, so we pull out the first object, put it in a variable, and then return that variable. So at any time from within any method in our ViewController class, you can call to this method here and get back an NS string containing the full path to our application's documents directory. So, in our viewDidLoad method, just so you can see what this path looks like, let's log it to the console. So, in our console here, we have, particularly for our app running on the iOS simulator, the full path on my Mac to the documents directory for our Simple Reminders app. Inside this folder is where we will archive our array to a plist file. So our next step is to write a method that we're going to call save that we can call to at any point, and it will take the reminders array at that current state and archive it to a plist file that we're going to name. If you look at the full path, the first thing you notice is when we actually save our plist file, we have to append another slash. So when we name our plist file, let's just place a slash at the beginning. So first, let's name our property list file, and to do this, we're going to create a constant in our .h file. So, using the define macro, okay, so now we have a constant called k_appDataFile plist name, and we've set our plist file name to reminders.plist. Again, here is where we will archive our reminders array to. So now let's write our save method. We can fully implement our save method with one line of code. Again, we're going to use the NSKeyedArchiver class. This is a class, obviously, that comes with Foundation that we never have to actually make an instance of because all it does is some static function for archiving whatever object you pass in to a file whose path you provide. So, very simply, NSKeyedArchiver, archive a root object. The root object is going to be our reminders array. And I just want to mention here that objects that you can pass to this method and the keyed archiver will know how to archive it have to conform to the NS coding protocol. This is a protocol that most Foundation objects that allow you to store some data conform to, and they use this protocol to both be archived and be unarchived. When you archive an object like an array, it'll tell all the objects it stores that they need to be archived, and if one of those objects is an array or a dictionary, it'll tell all the objects that it contains to archive, and so a chain of archives of calls from the root object all the way down to the furthest nodes until no more objects need to be archived, and they'll all be archived properly. So again, let's take a look at NSArray in the Apple documentation, and you can see conforms to NS secure coding, which conforms to NS coding. And these two methods here are the methods that an object has to implement to be able to be archived by an NS-keyed archiver. So you can actually make your own custom objects conform to this protocol if you want to make those objects able to be archived by the NS-keyed archiver. All you have to do is implement these two methods. Okay, so now let's actually archive our reminders array. So for the root object, we pass in our reminders array, and for the file argument, we're first going to grab the full path to the documents directory, and then we're going to append to that using the string by appending string method our file name constant. And that's it. Our save method is complete. So now again, we can call this method at any point, and our reminders array at that time, whatever state it's in, whatever objects it contains at that time, will be archived fully, completely to our plist file, our reminders.plist file. Next, we need a method to unarchive or load our plist file so that when the app launches, it can check to see if that plist file exists, and if it does, it's going to unarchive it and set the reminders array to the object that comes back from that unarchiving operation. So we'll call this method load. So first, we're going to use the NS-keyed unarchiver class to unarchive the contents of our property list file in the documents directory. We can do that like this. We're going to type our variable that's going to store whatever comes back from the unarchive operation as ID and cast it as an NS mutable array afterwards. So ID unarchived object equals NS-keyed unarchiver, unarchive object with file, and we can just copy and paste this here to insert the full path to our plist file. And then we're going to store whatever came back from this unarchive operation in our reminders variable. So reminders equals, we're going to cast the NS mutable array class onto this object, unarchived object. If a plist file does exist at the path we provided, then it'll be unarchived, and that object, which will hopefully be an NS mutable array, we store in our reminders instance variable. But if the keyed unarchiver failed, which in most cases means that there is no file at that location, it's going to return nil, which means empty. So now, when our view loads, or in the viewDidLoad method, we're going to try to load from that plist file. If it fails, that means we have no reminders array and we have to create one. So let's delete this line here. First, let's try to load. So self-load. At this point, our reminders array will either contain the unarchived reminders array or it'll be nil. If it's nil, we have to create an initial mutable array for our reminders variable to point to. Finally, we have to actually use the save method. So there's two places we want to use the save method. First, after the user adds a new reminder to the table view. So that'll be here in the alert view did dismiss with button index method. Right after we add the new reminder to the reminders array, we're going to save. And the other place we need to save is after the user edits a row. So text field did end editing. After we replace the old string with the new string, we're going to save. Alright, so let's see if it works. Okay, so let's quit the application. Open it back up. Perfect. The reminders array was properly archived after adding each row and properly unarchived when we launch the application. Now let's make sure it works with editing. So let's delete the first row and change the text for the second row. Perfect, that works too. There's one final step I want to implement just to make the app a tad bit more aesthetically pleasing. When we edit a particular row, when you press the return key, nothing actually happens. So first let's change the return key to a done key. We can do that in our cell for row at index path method. Text field return key type equals UI return key done. So let's see what that looks like. Okay, that's much better. Now finally, when the user does press the done key, let's make it so the keyboard disappears. So here in the text field should return method, again recall that this will be called by the text field when the user taps the return or done key, whatever key is on the bottom right of the keyboard. To make the keyboard disappear, we're going to have the text field resign its role as the current first responder. So any control object that the user is currently interacting with is set to be called the first responder. So we remove it as the first responder simply by calling to the resign first responder method. Let's run our app again. Perfect. Finally, we accomplished what we set out to in the beginning of the video. It was long and a bit tedious, but for the first time we've actually created a real application, an application that actually performs some function that users can take advantage of. From here, you can add any of the things we discussed in previous videos to your application. You could embed this in a navigation controller and, for instance, say, provide the user with different categories of reminders, where the first view when they launch the app is all their different categories, and then when they select a category, you display all the reminders in that category. You could even add some graphics to make it look a little nicer and not just like a standard iOS 7 app. Or more simply, you could even just change the colors. The color of the navigation bar, the color of the text on each row, whatever you like. Before we close this video out, there's one more thing I want to show you. So let's quit this application and close the project window. We're going to make a new, really simple application just so you can see that if in your application you need to save something, but it's something very simple and small, for instance like a setting, you don't have to archive to a plist file. You can actually use a class called NSUserDefaults, using which iOS provides developers a way to very quickly, minimally store some small pieces of data and then retrieve them later on. So let's take a look at how that works. Let's create a new project. Let's just call it User Defaults. And now in our main.storyboard, we're going to add a load button, a save button, and a text field. So alright, so first, let's add the IB actions and the outlets we need for all of this stuff. Let's connect everything. And finally, let's implement our load and save method. So first, save. We call to the NSUserDefaults class and we send it the standard userDefaults method, and this will return the global singleton NSUserDefaults object used for storing small pieces of data, again like settings for your app. So first we're going to save the text in the text field. To do this, we use the setObjectForKey method. So the object is the text field's text, or the NS string that contains the text in the text field. And then for the key, we'll use some constant k sum text. Then we have to call to the synchronize method. And then to retrieve that text in our load method, Okay, run the application. So first we'll put some text, save, quit the application, run it again, and if we press load, you can see the text we had entered when we pressed the save button is retrieved when we press the load button. Again, this is only for small pieces of data like settings. If you have a big array or a big dictionary, I certainly recommend that you archive that to a plist file and store it in your applications documents directory. Anyhow, that concludes this video. Head on over to video number 9 to see how you can download a movie from a server and play it on an iPhone.